I'm reading another label. Turns out that my ramen noodles, these are the good ones by the way, they're quite a status symbol, have sodium carbonate. All right. But, you know, I like reading labels, and chances are, folks, what you're going to see in your life is not a formula on one of these things. You're going to see a name. So we need to talk about the naming scheme for every kind of compound. Not only metal, non-metal, like we talked about last time, but non-metals combined with non-metals. There's different schemes for naming those things. So let's go talk about the name of virtually every compound you might see right now. Leek extract. Well, hi there, folks. Hi there. Mike here, and we are going to talk about nomenclature, or giving all kinds of compounds names. So we're going to focus on one particular broad kind of compound. That's where you have just two different kinds of elements. So you got atom A and atom B, and then we'll branch out into things with polyatomic ions and that sort of thing. But keep in mind that while we are using a scheme that's widely accepted to determine what the name of a compound is, then and therefore you need to understand that scheme so you can read a label, like me reading my ramen noodle package, and then knowing what that compound is and what its formula is from the name. There are two narratives, and that one is that there should be, what I'm saying is, no John Smiths. That is, that every compound should have its own unique name. So, for example, there's carbon monoxide, carbon dioxide, and that kind of thing. Number two is that we should only make the name as long as possible, or as short as possible. So we're not going to try to add in all sorts of other verbiage that isn't necessary. So you'll see that quite a bit as we go along. So you all learned about the different kinds of compounds last time. So I'm going to go and we're going to start with what we know the best, ionic compounds. So you remember those are metal, non-metal compounds, and they have specific ratios. If you remember the last video we just did, they have to combine in such a way that the net charge is 0. So here's what we're going to do. We're going to first talk about how to name the metal ion, and it depends on where the metal is. So okay, big picture here. Here's our periodic table. Most of the elements are metals. However, there's these pesky transition metals which are quite different than the main group. So let's just deal with main group metals first. Then we'll talk about those pesky troublemaker transition metals that don't obey the octet rule. That's the thing. In the main group, all the metals obey the octet rule. In the main group, the metals are in groups 1 through 3. So this is groups 1 through 3. If you number your periodic table, label it A. This is 1A through 3A. And oh, look what I did. I must have Freudian slipped. I put it in Roman numerals, which happens some later. So here's how you name a metal that is in the main group 1 through 3. So I just picked out some randomly. So for example, sodium, you just call it sodium ion. That's it, just the name of the element, and then throw the word ion in there. And I'm going to tell you honestly that one thing we do in society is we don't put the word ion in a lot. Even if you're talking to a chemist, they'll say, boy, there's a lot of lead in the water. And then one chemist understands the other chemist really means lead 2+. Or, you know, you got a lot of calcium in the water here or something, and the other chemist knows that it's calcium 2+. So we drop ion, but if you want to really be exact, you should say, well, you know, there's a lot of silver ion in this sample, or I'm drinking a drink that has barium ion in it, that sort of thing, all right? So all you do is say the word of the name of the element, and then you throw the word ion in after that. Now, what's going to happen is later on we're going to talk about compounds where these combine with other negative ions, and then that's where you get the name. But do you notice that I didn't have to say what the charge of these ions is? So I didn't say calcium 2+ ion, I didn't say sodium +1 ion, I didn't say the charge, and that goes back to the narrative of not putting any more information in that isn't easily accessible. So well, why is that easily accessible? From this, you could go look up what group each of those ions is in, and you'd say, hey, calcium is in group 2, so that's a 2+. So it all boils back down to the octet rule. Now, I'm going to show you a figure from the OpenStax book, which shows you what happens with transition metals. Now, I don't know if you noticed, but in the transition metal part in that figure, there are multiple kinds of ions possible for each element. And the reason I can say that happens, if I had to speak for nature, is that these elements are way too far away in numbers of electrons gained or could be gained or lost to get to a noble gas number of electrons. So they can't obey the octet rule. It's too much work for nature. They have their own rules. They just have multiple kinds of rules that happen. I'm going to just only show you a little bit of that at a time. So for example, iron 2+ is one of the 2 kinds of charges that form for iron. And that's very important, because that is the charge of the iron in your hemoglobin. And so there's 2 ways to do this. I put down new school, old school. And I'll tell you what, folks, new school, unlike the new school numbering of the periodic table, this new school way is much better because it does not involve any memory. All you need to do is look on a periodic table and read the name of the element, and then put the charge in it in Roman numerals, unfortunately. Roman numerals are what they still use. So in new school way, what we would do is the iron in your hemoglobin, we would call that iron 2 ion, iron 2 ion. And that's simply the number in the parentheses is the charge, positive charge of the ion. Let me be real specific here. Say that again. The number in this parentheses in Roman numerals is the charge, positive charge of the ion. The old school would be, you'd call it ferrous ion. And what does that mean? Well, there's different prefixes. And so I want to tell you the old school, but I'll tell you the new school way is way better. The iron charge that is in rust is iron 3+. And so we would just call that iron 3 ion. In the old school way would be to call that ferric. So the old school way, what you do is you take like the Greek or Latin sort of prefix of the element, which itself you have to know by memory what it is, so it's kind of a crummier system, but it's still around. And then you have these prefixes us for the one that has the lower charge and ic for the one that has the higher charge. Now, when I talk to my students about this, I say, you go and you want to learn both of them, that's fine, but I only require them to know the one where you just put the charge in Roman numerals and you say that's it. So there you go. Us is the lower charge and ic, and it's a more faulty system. But if it still is there. A lot of this stuff is just like the metric system. It hasn't been completely adapted. So if you go into the vitamin aisle and you're looking for iron supplements, you're going to go see a compound called ferrous sulfate, and that is Fe2+ combined with SO4 2- FeSO4. See? So we're going to end up slapping these names together. Now, I'm giving you an example. And by the way, you say, hey, that's not a big deal, 2+, 3+. No, that's a big deal. If all your hemoglobin, the iron in there, were to convert somehow from iron 2+ to iron 3+, you would encounter a condition called death. So it's really important. to know that those are not just, you know, sort of subtle differences. They're kind of important. Let's use tin as an example. You notice the same kind of pattern. Tin happens to make a 2+ and a 4+. So let me say this again. When I teach this to my students, I don't make them memorize the charge of the ion in a transition metal. There's ways you can find it out. If it's combined with something else and you know the negative ion charge, then you can go figure it out. But I don't make them memorize that. But just for trivia's sake, tin makes two different ions. One's a 2+ and one is a 4+. And so what we would do is we'd call the one tin 2 and we'd call the other one tin 4. Or if you use the old school naming system, you would call it Stan-us and Stan-ic ions. So that's how we deal with the transition metals. Now remember, we got to give as much information as we can, but not too much. So let's talk about negative ions, and then now we'll have talked about every single kind of positive ion, every single kind of negative ion, and we can slap those two names together and make compounds, and that's how you name a compound. So let's talk negative ions next. Okay folks, and you know the good news is ain't no transition metals with negative ions. They're all things that are non-metals. So negative ions are always going to be close to the noble gases, and they're going to be gainers of electrons, and they're going to be negative ions. So I'm just going to go ahead and pick at random. I'm going to go ahead and take Br-, which you can see is in group 7. Now, the element name is bromine, but we're going to take away the suffix and then we're going to replace it with "ide." So what we would do is we would call this bromide. And you know what? You don't have to call it bromide ion. When you have "ide," it's known that it's got to be an ion. That suffix "ide" means it is a non-metal single atomic ion in the in the periodic table that has gained some electrons. So what you could do is, if you said let's go down the whole halogens. So if you go down group 7, fluoride, that probably sounds familiar, right? That's what's in your toothpaste. Fluoride ion. Well, you don't even have to call it ion, fluoride. We have fluoride in the water. And if you like that kind of thing, some people don't like fluoride. But fluoride, chloride, bromide, iodide. See? And I didn't have to say anything about the charge, because the reader of the name can go figure out what its charge is by its position in the periodic table. So if we were to go and say O2-. How did I know it was 2-? It's in group 6. 6 minus 8. This is oxide. Right? And then you'd have sulfide. And if you had like P3-, that would be phosphide. Now we're going to go ahead and we're going to slap two things together and we're going to name some compounds, and I'm going to do it right along with you. And I'm going to go take some of the positive ions we've already discussed, and we're going to go and say, we're going to go back to our formula writing thing, where we're going to go and put them in the proper ratios, and then we're going to give it a name. So let's go ahead and say naming ionic compound. Let's just pick two things at random here that I already talked about. Actually, you know what? Let's take some of the ones I didn't already do. Let's say we were going to go and we were going to take potassium ion and phosphide ion, or phosphide, potassium. Well, you don't need the word ion anymore if they're going to combine. but you would get a formula, and the name of it, we would just bring these two together, potassium phosphide. That would be the name. And then using what we already know, we can do whatever technique you want to do to find out the ratio. And we could do the switch the numbers thing where it's a 3 and a 1, you know, if you like doing that sort of thing. And or you could just go and draw out your positives and negatives, but that would have the formula K3P. That's potassium phosphide. Now I'm going to go over here in the naughty corner, and I'm going to do the wrong thing. And I'm going to say that we are going to have already slayed formulas, so you know that the formula here has got to be K3P. All right, and I'm going to say the wrong thing to do would to be call it tri, you know, put some prefix on it, tripotassium phosphide. And you see what you're doing there is you're making the name longer than it needs to be with that tri business. Now I know tri comes up, and di and tetra, all those prefixes come later with covalent compounds. And so so you see where we're evolving to here, folks? You know that that's K3P. By the way, I always do a joke where I say, hey, they found a compound in dog urine. It was called K9P. But you see, the bottom line is there's no such thing as K9P. It's got to be K3P. Let's go ahead and take a transition metal and, you know, like Fe2 plus O2 minus. And let's take both of the forms of iron. And let's make a formula, and let's make a name for each of them. Well, you can see that the formula for iron and 2 plus and 2 minus would be FeO. And then, you know, using the stuff we talked about in the last video, 2s and 3s, this would be Fe2O3. So how would the name be different? You can't have them be called iron oxide. There's 2 kinds of iron oxide. So this would be called iron 2. This would be called iron 3. And in both cases, this would be oxide. So this would be iron 2 oxide. Now notice, that doesn't mean there's 2 irons. There's only 1 iron. But that means that the charge on that iron is a positive 2. Fair enough? This would be iron 3 oxide. So, you know, what you need to do when you look at a formula, you need to check your metal, say, hey, where's it from? What part of the periodic table is it? Is it from the transition metals? You look up where iron's position is, and you say, yeah, I got to say what the charge is on that, because there's more than one possible way you could make iron combine with oxygen, right? In a 2 to 1, or in a 1 to 1, and a 2 to 3. The old school name, by the way, this would be called ferrous oxide and ferric oxide. So, you know, I think we've covered every single kind of ionic compound. And so what we're going to do is some more practice. And we'll go from having a formula to a name, and then from name to formula. And then we'll have slayed everything ionic. So let's do a little bit more practice next. Okay, folks, here we go. The rubber is hitting the road, and we're going to do some actual, we're tasked with providing the name of each of these compounds. So I'm going to start with CaCl2, and I'm going to go and I'm going to say, okay, that's calcium ion, and that's chloride ion, and then I'm going to go find the position of the metal, and calcium is in group 2 of the periodic table. And so I don't need to say anything other than calcium and then chloride. This is calcium chloride. That's it. Not calcium dichloride. You just threw a di in there for no reason. The reader can figure out or knows that there's only one combination between calcium ion and chloride ion, and that's it. So, okay, now this one's trickier. That's titanium. Titanium is a transition metal. There's titanium right there. All right. So titanium is a transition metal. And now you have to indicate the charge. I'm going to go, it's titanium oxide, but I'm going to put parentheses in there. Inside the parentheses is going to go the charge of the titanium. So you got to go figure it out. Now, see, remember I told you, you don't have to memorize in a lot of cases what each element in the periodic table of the transition metals do in terms of what kind of charges they make. You can find it out. So I can figure out that I have an oxygen in there, and that's a -2, but there's 2 of them. That's a total charge of -4. So what's the charge on the titanium? Whatever adds up to 0, +4. That is titanium 4 ion in there. So this is titanium, Roman numeral 4, oxide. Some people will, I've seen my students goof it up where they say, oh, that's titanium 2 because there's 2 oxide. Nope, you're confusing that with the next scheme we're going to talk about, which is how you name covalent things. Covalent things, you got to be specific about how many of each atom there are. So that's how you deal with that. Now, I don't make my students memorize polyatomic ions, but this is called nitrate. And of course, that's aluminum. Aluminum is in the main group. Now you got to watch out. I know it's right next to there's a big old gap there, and then you got aluminum, but it's still in group 3. So it's still in the main group. It's not in these 10 columns that are the transition metals. So I'm going to say that's aluminum ion. Aluminum is always a +3, period. And so that is just aluminum nitrate. That's it. So when the metal's from the main group, you just slap in the name of the element in there. Once again, I don't have to say trinitrate. It's wrong to say trinitrate because of the first sort of tenets of naming is that you are going to make the name as short as possible. And so that is aluminum nitrate. Fair enough? I think what's easier is when we go from name to formula. All right, so I'm going to go ahead and I'm going to go and give a name. Copper. Two. Oxide. Let's figure out what that is. Well, here's the nice thing about being given the name. The name tells you exactly what each thing is. So, you know, I got copper 2, copper 2+. Oxide is in group 6, O2 minus. That is CuO. Copper has 2 ions. There's a +1 and then there's a +2. And if you've ever seen a penny that has been oxidized or has, gotten wet, you'll notice that maybe you see some blue. That's the color of copper 2 ion. And then if you see green, that's the color of copper 1. So where do you see that? Statue of Liberty. What happened is she started oxidizing. She was the color of copper metal, the orangish bright color. And then she's starting to turn green now because she's been around quite a while. But that's okay. She's cool. Statue of Liberty's cool. Used to be able to go up in her head. That was something, but you can't do that anymore. I don't know why. Okay, sorry. So let's talk about another one. Let's say we're going to get the formula of barium fluoride. This one, actually, when they're in the main group and you're going backwards from name to formula, now this is a little bit tougher. You have to go find its position in the periodic table. And you have to go and say, okay, barium's in group 2. Right there. There's barium. And then fluoride's in group 7. So barium's in group 2. That's a Ba2 plus. And fluoride's in group 7. 7 minus 8. That is a F minus. You need to combine those in a 2-to-1 ratio. That is BaF2. That's barium fluoride, not barium difluoride. All the dis and tris and tetras are coming up next when we talk about covalent compounds, which I think we're ready to do. So give it a lot of practice. You know, go from name to formula and formula to name, and do it for ionic compounds. You got 2 kinds of metals, right? You got transition metals, you got the main group metals. So you got to watch out. You got to pay attention to which kind of ionic compound it is. There's 2 kinds depending on where the metal is from. Okay, let's talk about covalent compounds with nonmetals and nonmetals next. Okay, folks, next comes nonmetals with other nonmetals. Now, the funny thing is we haven't really talked about that a great deal. So it's a little bit tougher. What you've got are different. Here's nitrogen combined with oxygen. And there's no charges. It's sharing. It's totally different. So you can't really quite see why there's so many combinations. But because covalent bonding is so complex, there's a lot of different ratios that can exist. So now what we have to do is, one, we write them in the order of the periodic table still. So you notice that the nitrogen's on the left and the oxygen's on the right. But what are we going to call it? Nitrogen oxide? No, can't. I just wrote 3 different combinations of nitrogen and oxygen. So what happens is you still do the oxide fluoride thing. You know, the one that comes second, you put "ide" in there. But we need to be more specific about how many there are of each. So we have some prefixes. And let's go ahead and write those down here. Prefixes. And so if you got 1 of something, we call that mono. 2, di. 3, tri. 4, tetra. 5, penta. You know what? That's about all we need to do. So what we would do here is you would want to call this dinitrogen. And here's another thing. You would call it dinitrogen. Mono is for 1. Di is for 2. And then we would not put 2 vowels next to each other because that would just look silly. So this would be if I put monoxide, that looked like monoxide, and that would just look silly. So we just knock that off, and that's dinitrogen monoxide. Here's the thing, you can cheat. The next one, you know, is kind of looks like CO2. And if I said, hey, CO2, what's its name? You'd say, oh, it's carbon dioxide. So do you notice one of the ways we make the name much shorter is if there's a 1 of the first atom, we just knock the mono off of it. So we don't say mononitrogen dioxide. We just go ahead and we say nitrogen dioxide. All right, let's do the next one. You think about it. What would it be? It would be same as the one on the top. As far as the nitrogen goes, it'd be dinitrogen. Tetra oxide. Now you don't put 2 vowels next to each other, so this would be dinitrogen. Dinitrogen. Freudian slip. I call it dinitrogent. Sounds like something you have in your, you know, like laundry detergent or something. Dinitrogen, by the way, these are all 2 words, just like the other ones. Tetroxide. not tetraoxide, you know, but I would cut my students a little break if they said tetraoxide. Yeah, you know, but fair enough. So you see here, you got to recognize that with covalent, you need the prefixes. And you know what, folks? Just recall something you know already. You know, you say, hey, I know sodium chloride. Oh, that's ionic. And notice I didn't put any prefix. I didn't say sodium monochloride. And you say, hey, CO2. I know that's CO2. And I know that this is, you know, you got two kinds of, you got carbon monoxide. And then you got carbon dioxide. Fair enough? Now, let's find, how about this? Dihydrogen. Monoxide. What is that? See, it's easy when you go from, you know, that would be, two hydrogens. And then that's funny, because actually water is one of the compounds that's so prevalent. We actually give it a buy and we say we ain't naming it nothing but water. But if you wanted to, that would actually be the technical term, and you could fool your friends. You could say, oh geez, I got dinitrogen monoxide on me, and that just means you took a shower or something like that. But going back and forth between from name to formula when it's covalent, super easy. It tells you right in the name what it's going to be. So I'll take one less silly, and this will be our last one. Phosphorus trioxide. Right? Phosphorus, P, trioxide, O, PO3, right? So real easy from going to name. You just kind of, it tells you right there. But what my students will do is they'll really understand this really well, the prefix thing. But then they'll apply it in the wrong place. So I don't say titanium dioxide, I don't say calcium dichloride, I don't say aluminum trinitrate. That doesn't belong there. You don't need that. The charges dictate what the ratios are, and then making the name as short as possible will do that for you. So that is the way to name every single compound you'd run into. Just to recall here, you have ionic, then you got covalent. You have ionic where the transition, where the metal is not a transition metal, and then you just slap the two names together, really. You know, something like strontium chloride, something like that. And you have something where the metal is a transition metal. You have to be very specific about what the name is. You have to say copper 2 chloride, or something like chromium 3 oxide, and that's just saying the name is what's in that parentheses. And then you look at this, and if you saw just nonmetals, you have to put prefixes in there, and you'd have to say, nitrogen monoxide, or you'd have to say something like silicon dioxide. And so you got to watch out. You know what side of that staircase you're on, depending on, so you know which set of rules to follow. Folks, this has been a long one, but now you have the ability to almost every name you read on a label, except for the really complex ones that we didn't get into. You have the ability to decipher a lot of names and take formulas and give them the proper names. And in this age of information technology, you got to be right with this stuff, right? It's all searching for strings of characters. If you go and Google something like barium dibromide, you're going to get some information of somebody who gave it the wrong dang name, and you don't want that kind of information. All right? So, okay, folks, we have just finally slayed the rest of Chapter 2 in the OpenStax book, and you probably had enough for a while. So take her easy. Enjoy your day. Bye now.